Hello and welcome back to my organic chemistry series of videos. This is Chemistry with Kimberly. Now you may recall that I mentioned previously that I would cover acids and bases in this video as well as resonance structures. Well, I'm actually going to divide the topic into two. Today I'm going to cover acids and bases, and the next video will be resonance structures. So let's get started. The Bronsted-Lowry definition of an acid is a substance or compound that donates an H+. Therefore, a base will be a substance or compound that accepts an H+. Bronsted-Lowry, acid donates H+, base accepts H+. The Lewis definitions for an acid is a substance or compound that accepts an electron pair. And a Lewis base will be a substance that donates an electron pair. So a quick review: a Bronsted-Lowry acid donates an H+ or proton, a base accepts an H+ or proton, a Lewis acid accepts an electron pair, and a Lewis base donates an electron pair. Now let's look at a couple of examples. So here I've drawn three different molecules. The first one, by Bronsted-Lowry definition, is a base because it wants to accept a proton to become an H3, or an amine group. The second compound is propanoic acid. So this is a good time to remind you all to review naming organic chemistry compounds as well as the functional groups. Propanoic acid, by its name, is obviously an acid because it wants to donate that proton. And finally, we have a cyclohexane ring with an amine group. That would be called cyclohexamine. I won't bother drawing the name out, but this is going to be a base. And I'm missing a plus charge here. So it's actually, my correction, it's going to be an acid because it's donated a proton to become a cyclohexylamine. Now let's look at some important chemical reactions with Lewis acids and bases and with Bronsted-Lowry acids and bases. So before I tell you which classification this one is, I'll draw it on the board and give you a few seconds to see if you can guess whether or not it's a Lewis acid or base reaction, or is it a Bronsted-Lowry acid-base reaction. So this is a good example of a Lewis acid-base reaction with the iron tribromide. Let me correct that, that should be a 3, reacting with bromine. This is a very common bromination reaction in organic chemistry. The product, it's going to be FeBr4 plus, the positive charge, plus Br minus. Now, one of the things you may notice is that in the process of creating the products, we have produced compounds which have charges. And it's important to look at your charges to make sure that if they balance, that's a really big clue that you've actually performed the reaction properly. So we have a plus on the FeBr4, a minus, which totals to 0. We have two compounds on the left-hand side of the equation which have no charge. So therefore, that's a clue that I did the problem correctly, and it is, in fact, correct. So for our last reaction, to review for this section, So again, this is the Bronsted-Lowry definition of an acid and base that I'm looking for, with an acid being defined as a proton donor, a base being a proton acceptor. So here is the compound that's going to accept the H+. The plus is obviously attracted to the minus sign, and the resulting compound is or ethanoic acid. That makes the H+ the acid, and the CH3CO2 is the base in this reaction. So that's going to do it for this lecture on acids and bases. Just a quick review. There are two important types that are found in organic chemistry reactions. That's the Bronsted-Lowry acid-base definition, as well as the Lewis acid-base definition. Thank you for watching the video. I'll see you in the next video.